Hello, everyone, and welcome to the Anti-Doping Podcast, brought to you by the Partnership for Clean Competition. I'm your host, Dr. Marie McNeely, and today we are joined by our guest, Dr. Vidya Mohamed-Ali. Listeners, Vidya is Scientific Advisor at the Anti-Doping Lab Qatar and Deputy Director of the Center of Metabolism and Inflammation at University College London. In our conversation, Vidya will tell us more about research at the Anti-Doping Lab Qatar and also a recent PCC-funded study exploring use of drones in anti-doping. So Vidya, welcome to our show today. How are you?
Very good. Thank you for having me, Mari, and hi to everybody who's listening.
Excellent. Well, Vidya, we're looking forward to learning from you today. And I'd love to start by just talking about your main responsibilities and what you do as scientific advisor at the Anti-Doping Lab Qatar.
In general, as a scientific advisor, I'm responsible for providing the leadership of ADLQ with advice on scientific issues. And I do this as part of an internal research and education committee, which comprises of a team of accomplished scientists, some from within ADLQ, and there are a couple from outside. And I try and provide advice on a range of activities within the organization, including research initiatives, training, and education. And I also try and bring in collaborations through serving on committees outside of ADLQ, such as the one that I serve on IOC, the Medical and Scientific Committee, as well as my various committees in University College London. Specifically, my duties include reviewing research ideas, protocols submitted by our scientists, and this can come from scientists at any level of our organization. And they can come from either within ADLQ or our scientists in collaborations with group outside, either national or international. I then determine the project's relevance and adherence to ADLQ's mission and vision, project complexity, determine our capability to fulfill the aims of the projects in terms of people, technical aspects, statistics, bioinformatics backup, funding, either internal or external. And we, as IREC, the Internal Research and Education Committee, approve the project. And once it's been approved, then I also monitor and check the progress that is achieved throughout the process. The initial process is, of course, making sure that there are ethical considerations have been considered and that IRB submissions are made, the scope of work, attend some pre-project presentations. And then once the project is properly up and running, review progress reports, and if possible, help with any difficulties, usually things with recruitment, or expanding collaboration if they've run into a technical impasse. Finally, I also review manuscripts. Sometimes I actively take a role in writing them if necessary, and acquire wherever necessary and maintain critical knowledge to be able to support our scientists.
Very interesting. It sounds like you've got a lot to do there. And you actually joined the lab back in 2012, shortly after it was established. So, Vidya, what has it been like seeing ADLQ grow and develop over the past 10 years now?
Overall, very satisfying. In bits, thrilling. And I'd say hopeful for even more progress in the future. So I joined ADLQ, as you said, in June of 2012 during a short sabbatical from University College London. And then I came on board full-time as director of the research lab, the Life Sciences and Research Department, it was called at that time, shortly after. And I stayed here full-time for 5 years until the end of 2017. And from 2018, I've been the scientific advisor. In 2012, when I got here, especially the research labs were not ready. So we were actually based in a little annex just next door. So I was involved in planning, ordering and receiving equipment, recruitment of staff, both from within the local pool and also from outside. And again, when we had to look outside, they were expat scientists from all over the world, while also arranging appropriate academic training of our local scientists. But if you visit us now, you'll see that we have state-of-the-art labs conducting research that's globally competitive, and young local scientists who've done their BScs, their masters, their PhD with us, gradually able to take on more and more senior positions with currently support from expat scientists. And I'm hopeful, perhaps even quietly confident, that maybe in 5-10 years' time, ADLQ, like all other WADA labs, will have trained, competent local scientists at every level, from trainees to director, And of course, with room for those from outside, with thriving national and international collaborations, and carrying out both service and research goals of the institution.
That's fantastic. Well, it sounds like things have come a long way. I'm curious to hear a little bit more about your origin story, Vidya. So how did you initially get interested in anti-doping research?
In a very indirect way, because I'm really an endocrinologist or a physiologist and an academic scientist for over 30 years. I've been a member of the Endocrine Society since 1992. And it's through this that I initially became aware of doping in sport, especially its effects on health. In 2008, the Endocrine Society produced a positional paper on the illegal use of anabolic steroids, having dangerous side effects, not just during the use, but being harmful years after athletes stop abusing steroids. And this happened to coincide with me being invited to talk at a symposium in Qatar about my research by Professor Mohamed-Ali, who was the Director General of Qatar, which is an orthopedic and sport medicine hospital, which since 2015 is an IOC research center for the prevention of injury and protection of the athlete's health. During this visit, I met a few people from IOC, and this really got me thinking and reading about anti-doping research. And again, in 2008, while still at UCL, I started my initial collaboration with Qatar, and then in 2012 was invited to come and join ADLQ when that opened.
Oh, very interesting. And we mentioned in the introduction that you've got this position, of course, at ADLQ in Doha, but you also have a position at University College London. So how do you balance your roles and responsibilities across those two positions?
The work in the two places is actually very complementary. I mean, kind of things that we cannot do here, we often move it across to London and do it very quickly. So it actually enriches my work by being in these two sites. Two very different working environment, one academic and the other more analytical. And there's a lot of crosstalk between that. So anything that we want done analytically, many departments and many colleagues within the university send it over to the Anti-Doping Lab. And surprisingly, the silver lining, of course, of the COVID pandemic has been that we've all realized that we can be on opposite sides of the world and still work together relatively easily. So I'm in Doha every 6 to 8 weeks. Talk to various members of the research team every day. So I haven't really found it an issue. I've actually found it pretty enhancing and enriching. And I think the same applies to the research itself. And of course, having been here 5 years full-time before then.
Definitely. So can we dive into a little bit of the details of your work there at ADLQ? Can you tell us more about what are the current research priorities there?
There are several, but one area that we've been concentrating on quite a lot is really blood doping, which refers to the various ways by which an athlete might artificially enhance the ability to increase oxygen to your exercising skeletal muscle. And this is our current research priority. And we're doing this addressing this in several ways, because one way of doing this is actually by using drugs. The drug is synthetic EPO, various recombinant erythropoietin. So initially we've published, a couple of years ago, I think now, we've published on modifications to the available EPO assay to make it faster. And we're working on generating some interesting camel-derived antibodies that may have better specificity and affinities to erythropoietin, and perhaps improving it that way. We're also working, but in collaboration, looking at synthetic hemoglobin-based oxygen carriers, HBOCs. And though this is not our own, this is very much a collaborative project. The main focus for us now within this area is actually looking at blood transfusion, both homologous and autologous. And we've taken two approaches for this. One is actually molecular, where we use techniques like autosomal short tandem repeat markers, as well as some nucleic acid-based markers, still in early stages of development. And we've got one of our young scientists really taking a lead on it. And the other approach that we address this, and we've had some success, is using metabolomics, specifically untargeted metabolomics. And we found a panel of metabolite markers for autologous blood transfusion, which is extremely exciting. We've recently published this. However, still early days, because we need to validate and confirm the robustness and reproducibility of these markers. But it's certainly a step.
Absolutely. Well, it sounds like you've got a lot of fantastic projects going on there in the lab at the moment. And we touched on in the beginning here that you've been working sort of in a completely different area of anti-doping research in a project funded by the PCC to investigate use of drones in anti-doping. And I think this is absolutely fascinating. So can you tell us a little bit more, Vidya, about the background of this project and why you wanted to pursue this particular line of research?
First, of course, just thank PCC again for the funding. Funding is always difficult to come by, always very grateful to have it. So drone delivery is a really, really rapidly expanding innovation with applications ranging from hospitals, medical logistics to parcel delivery, especially when speed is of the essence. This cutting edge technology has yet to be tested for the transport of anti-doping samples, especially during major sporting events. The safety and reliability of drone delivery, especially in bad weather, inclement weather, has raised some concern. And there's only limited data on the stability of biochemical, hematological, metabolic factors following this form of transport. We also wanted to address the newer analytical matrices, such as dry blood spots, and techniques such as metabolomics, to get some idea if they are at all affected by this form of transport, either favorably or adversely. This is a collaborative project between the International Testing Authority, who actually initiated this, and the Anti-Doping Lab, and Rigitech, which is a small, medium Swiss startup based in Lausanne. So we conducted a proof of concept study to investigate whether drone delivery is safe, secure, reliable, and in compliance with the WADA code for international standard for testing and investigation provisions. The drones were actually capable of landing and taking off vertically, so it required very little space other than a little bit more than what you would need for parking your car. And they were provided and piloted by Rigitech, the company that I mentioned earlier, with the capacity to carry a payload of about 2.5 kilograms and in temperature-regulated compartments. We conducted 5 flights in March and over a period of about 4 days.
Oh, interesting. So you mentioned some of the considerations here. You've got to think about the weather. You've got to think about the weight. What about distance?
Distance is an issue. We were really in Doha. It wasn't a major issue. So we considered a couple of distances based on how far away the stadiums are because of the World Cup. And we took a kind of median range. We took the nearest to us. We've actually got Khalifa Stadium right next door to us. And we thought 5 kilometers is more than adequate to cover back and there. And then the other distance we considered was 20 kilometers. And that would cover, out of the 7 stadiums, 5 of them, or maybe even 6 of them. I think there's one that's further away, that's about 60 or 70 kilometers away. And that's the only one we couldn't reach. So those are the considerations for us in Doha. So it suits us quite well. It's far enough away for you to expend quite a lot of time if you were going by car, but it's close enough for the drone to cover without too much difficulty.
So can you go into some of the details then about this PCC-funded study and what were the specific aims that you were tackling in this particular study?
The study tested the hypothesis that drone flights do not impact blood, urine, and dry blood spot sample quality, and consequently complies with Article 9.3 of WADA ISTI. To test the above hypothesis, we collected samples prior to and after delivery by car and drone over distances, as I mentioned, 5 kilometers and 20 kilometers in relatively high winds and temperatures.
Very cool. It sounds like you're answering some really important questions there. And I think these drones, it seems like, have a lot of potential. So Vidya, can you tell us what are some of the benefits that drones may be able to provide if they're implemented in sample testing and delivery applications in anti-doping?
Because we want quite a quick turnaround in anti-doping and we don't want samples to be sitting, so speed is certainly of the essence. So the first benefit for us is speed. Next is safety. Can't compromise on safety at all. And overall, no mode of transport is completely free of risk, nor are the drones. But its track record is better than by car. It's also environmentally friendly because it's fully electric, and it has the ability to be tracked throughout the process. So chain of custody can be maintained throughout the process, from the drones being loaded up with the samples right through to when the samples are delivered to the lab. So at this point, I think it's also important to point out that it's not robots that are delivering the samples. These drones are actually operated by trained pilots so that the safety aspects were well covered. And anti-doping professionals who performed the tests were actually trained to load the samples into the drone so that we eliminate the risk of contamination. Once loaded properly, these aircraft took off, flying manually or following a flight plan. And in navigation mode, they were able to send back data on the various points of their flight path regarding weather conditions and wind speeds. And these can all be analyzed later. The samples were actually stored in special containers inside the drone. And these drones were able to carry up to 25 kilograms, depending on the configuration used. But though we used the 2.5 kilogram configuration, so can transport, if we needed to, multiple numbers of samples. So once the drones completed its flight and arrived at the lab, the trained staff collected these samples to take them to the sample collection area. And the drone sample box is all wiped down and sterilized after every delivery. So you can see all the advantages: speed, safety, environmentally friendly, completely trackable, and minimizes any kind of contamination from one delivery to the next.
Absolutely. Well, I think this is so cool. And I have to ask, you did mention there are expert trained pilots during the study and you would anticipate during normal operation, but did you get a chance, Vidya, to try or test flying the drones?
I have to say there was a lineup of especially our young male scientists. For whatever reason, we didn't have too many of them. My hand-eye coordination in any of these things would be too scary. So I don't think the guys would let me anywhere near it.
That's fair.
Yes, I would have loved to have had a go.
That is fantastic. I've tried flying just kind of little recreational drones and it's difficult, I will say. So the trained pilots, I'm sure, have many hours of experience in this.
Indeed. And the drones were far too precious in terms of expense for the company to let us anywhere near it. They were happy for us to let us film it.
Of course, of course. So Vidya, I have to ask also, do you have results or findings from the study that you can share with me and our listeners?
At present, we can only talk about the drone performance. The delivery times over the 5-kilometer distance that I talked about was 5 minutes for the drone, as opposed to 9 minutes by car. And over the 20-kilometer distance, it was 12 minutes by drone and 34 minutes by car.
Oh, wow.
The temperatures that week was between 29 to 32 degrees centigrade, which is pretty normal for that time of year, with wind speeds ranging from about 12 to 20 kilometers per hour. But none of this detrimentally affected the drone performance. And as I mentioned, the drones are fully electric, so much lower environmental impact relative to the car. And these are the only results we have currently. We've just received the metabolomics data. In fact, we got them yesterday, but sadly, we haven't had a chance to do any comparative analysis with these as yet. We're also waiting for the results of the urinary steroid profile, which should be ready, I'm told, next week or in about a week or so. So we will have a report out and send out a manuscript for publication within about 8 weeks.
Fantastic. Well, listeners, stay tuned to see the full results of this exciting project. And you mentioned some of the conditions that the drones were flying under. I guess when you think about the future role of drones, are there particular situations or conditions that you think they may be best implemented in?
I mean, they're ideal for major sporting events, such as what's happening just now, the World Cup, perhaps Olympics, when the roads are likely to be very, very congested. And you're talking about multiple venues, and the samples have to come to a central lab from these multiple venues. I think that's where they really come into their own. However, of course, in the medical field, they've been used to delivering tests, especially COVID tests, to all sorts of remote areas. And they've been very useful for that. But for us, from an anti-doping point of view, they are ideal for safe, quick delivery of anti-doping samples during major sporting events.
Excellent. And we touched on some of the exciting projects that you're working on in the area of blood doping earlier in our conversation. And I'm curious, are there other particular projects in the lab that you're working on right now that you're maybe just really excited about, Vidya, that you want to tell me and our listeners more about?
I think one of the things that we've spent quite a lot of time at ADLQ developing is our metabolomics platform. in this era of precision medicine, omics is the thing, and omics is certainly the thing that's coming to anti-doping research as well. And this was set up in collaboration for us, Metabolomics, with Metabolism. And the platform required significant amount of input. I think it was about $5 to $6 million to set it up. And we had a lot of our scientists go and be trained. And the platform is accredited by Metabolism, and they curate all the samples for us. This then means we can actually do metabolomics on projects that are of real importance in anti-doping, the holy grail projects in anti-doping. So looking for markers after growth hormone administration is one of the ones that we're doing. We're doing this with WADA, where growth hormone has been administered at 2 different doses. And we've actually done the analysis, and we have got a panel of metabolites. We're still in the process of writing this project up. That's really something we're very excited about. And the other one is, again, autologous blood transfusion. Again, we've found a panel of metabolite markers that seems to really mark autologous, having had the transfusion itself, but it's still in its early days. We're really needing to validate that. So that's really an area that we feel very excited about, and we want to take this forward, this platform that can actually do quite a lot, the metabolomics platform. And we're using it now to address 1 or 2 of the most important, which is kind of growth hormone administration and autologous blood transfusion.
Fantastic. And I think being able to identify and detect these substances is a big challenge. But I guess thinking about your research right now, what are some of the biggest challenges that you're facing, Vidya, in doing your anti-doping research?
I think the biggest challenge and challenges really come from the use of endogenous substances as dopants. We all produce growth hormone. So when you're using growth hormone or insulin or EPO as the dopant, then as they are endogenous, the onus of proof is really on us to be sure that this is not due to some natural phenomena or genetic or epigenetic factor, but is rather a willful desire on the part of the athlete to cheat. So that's the really biggest challenge, I'd say. And then, of course, there's the validation of our findings once we've actually found a panel and bring it to the arena of routine testing. So it's pretty much like any other research. Once you've found your markers or you've found the answer, then you have to actually bring it into routine practice. Overall, it's again the need to stay ahead of the minority of athletes and their entourage who are determined to find ways to cheat.
Definitely, because I think it is dynamic. There's always new things coming out, new things that you need to be on the lookout for. And I think you've had some exciting successes so far, certainly in your work in anti-doping. So I guess, Vidya, do you have a favorite anti-doping research success that you'd like to share with us?
I have 2 favorites rather than one. So a little bit greedy here or a little bit not very modest. But we're a young lab, so we're kind of want to show off a little bit. Mm-hmm. We were one of 2 groups within the anti-doping research community that were investigating 20-hydroxyecdysone. This is a dietary supplement-derived ecdysteroid. Ecdysteroids are insect hormones, but they've also been identified as coming from some plants as well. But they have the ability to enhance sport performance through favoring loss of fat mass and have anabolic effects. We actually published on the analytical strategy for the detection of 20-HE and its metabolites at about the same time that WADA put 20-HE on the monitoring list. And we are now one of the WADA labs that regularly test for 20-HE in all urine samples that we receive. So that was very exciting for us, and we really see that. And we add on to that, and again, because of my background, one of the differences in the research that we do at ADLQ is we don't just look to identify markers of dopants. We often go on to study their potential mechanisms of action, especially effects on blood flow. So we found that 20-HE has vasodilatory capacity and may be bringing about this effect mostly through a nitric oxide pathway, but seems to be independent of the estrogen receptor. So this is really why it qualifies as one of my favorites. And more recently, we used untargeted metabolomics to analyze serum and urine samples for biomarkers of autologous blood transfusion. And we were thrilled to find a panel of 9 metabolites that seemed to remain altered 7 days after the transfusion. And this is the first study to identify a panel of metabolites from serum and urine as markers of autologous blood transfusion. So we really hope now we're at the stage that we really need to reproduce this in a new group of subjects and independently validate these results. So ultimately, again, if proved robust, could be universally adopted to detect autologous blood transfusion. So those are my two rather than one favorite.
Well, Vidya, these are fascinating projects. Congratulations to you and the team there on these successes. And I love that you guys are able to work on everything kind of from the basic science research, understanding these mechanisms, all the way through to applications in some of these really important projects in anti-doping research. So looking forward now, Vidya, what are some of the future directions and research projects that you're hoping to address?
Having made some of these really exciting advances and finding markers for autologous blood transfusion and for the growth hormone administration using our metabolomics platform, we're really keen to take this forward. And to do this, of course, we don't operate in silos. We have to be very collaborative, and that's what enriches us. And we've recently formed a collaboration with 3 other WADA labs with the aims of this consortium to really set up assays for the metabolites that we identified and then validate them in the new samples. So it really helps us get all that expertise from the 3 other labs, including ourselves. And we also hope to expand very soon our molecular capability, especially for authentication of sample identity. So those would be really our future direction, and that should keep us busy for a good little while.
Absolutely. And I know when you're planning for these future research projects and when you're thinking about the big questions you'd like to address, oftentimes things like funding, staff, technology, feasibility, all these details have to be considered. So if we took away those barriers, Vidya, and gave you all of the resources you could possibly desire, what is the one problem in anti-doping science that you would most want to solve?
For me, in research, whichever project you're immersed in at present tends to always be the one you most want to solve. It becomes your favorite. It's the one that really absorbs all your energy. So thinking about it, the planned expansion of the athlete's biological passport, which gives us a personalized prospective view of fluctuations in specific factors in an athlete, which currently focuses on changes mainly in the hematological factors, and is soon being expanded to include an endocrine model. If we could use metabolomics to help identify an indirect metabolite panel, and that could then be added to the ABP, that would really be something. And if we can contribute significantly to this, it would really blow us away.
Absolutely. So I guess thinking about the types of barriers you face, what is the biggest barrier that you think is preventing you from being able to achieve this dream?
I think one is biological. Just finding the fluctuations that happen. Because when you take a drug, when you take a dopant substance, you either measure the dopant itself or you measure its breakdown products, and they're not there for very long. And that really poses a barrier in a big way. And the second barrier is, of course, we are geographically removed from a lot of places, but we overcome this isolation by forming collaborations. But it's so much easier when you can just walk down a corridor or walk upstairs, the kind of things that I have normally in UCL, we don't have here. So we have to overcome, and we have to be a little bit more creative about overcoming them, because I don't think funding or equipment are our most limiting factors.
Absolutely. I think these collaborations are key to sort of make best use of and leverage all of the different fields that contribute to anti-doping. And we've covered a lot of ground today. We've talked about a lot of topics. If our listeners are fascinated by your research, Vidya, and they want to learn more, what's the best way for them to do so?
I think, like most other labs, it's our publications, our conference papers, but we are currently developing our website. It should be up and running, we hope, in the next month or so. That's another possibility. And we're all emailable.
Excellent. Well, listeners, definitely check out those research papers. Take a look at their website once it's available. And Vidya, it's been such a pleasure to have you on the show today. Thank you so much for taking the time to speak with us.
Thank you so much, Mari. It's been a pleasure.
Well, it's been wonderful to have you here, listeners. Great to have you here as well. If you haven't already, it would be wonderful if you could rate our podcast and leave a review on your favorite podcast platform. And listeners, please note that the Anti-Doping Podcast features a wide variety of clean sport experts, and episodes may include statements and or viewpoints that do not necessarily reflect the views or values of the PCC. Thank you, and we look forward to seeing you on the next episode of the Anti-Doping Podcast.